So we've gotten to the part of two-step equations. This is review. This is something we learned last year. And a lot of us understand the process, but we still make mistakes with moving certain terms to one side. So we've done distributing, we've done combining like terms, and we've done one step. Remember, you must show each step to receive credit. So in order to do two-step equations, it's important for us to understand this. Our very first step always is we have to undo any addition or subtraction. Really what we're looking at is the constant term, meaning just the number. We discussed this last week. So let's go take a look at my first problem and what this might look like for us, okay? So I'm here on number 9. Remember, if you have to draw this imaginary river, you can. Because what I'm going to focus on is my variable, okay? I want that to stay on the left. And I'm going to bring everything else over first. Well, I need to first undo any addition or subtraction. What's happening here is I'm adding 8. So I must subtract 8. And if I do it to the left, I must do it to the right. What happens is this cancels out, and I'm left with 6x equals 50 minus 8 is 42. Everyone with me so far? Now, once I've done that step, I'm at my next step of undoing multiplication or division. That's it. My next step, I'm either going to multiply or divide, always. So what I'm looking at is I'm looking at what's happening with this variable. Well, I don't see a sign. I have a number touching a variable. That means right now I am multiplying. So to undo multiplication, I divide. Therefore, I get x equals. And what we want to look at is this. This here, while it's a fraction, it says 42 divided by 6. Can we do that in our head? The answer is yes. It gives us 7. Therefore, that is my answer. Sometimes it doesn't work out evenly, so you can leave it as a fraction, and we're going to see that. So let's go to our next problem. I'll do number 10 with you. So if I cut this in half, what I'm going to do, I'm going to first undo any addition or subtraction by adding 5. Why am I adding 5? That's because it was being subtracted. So to undo subtraction, I add. Okay. Oops, I'm sorry. I'm adding. So I actually need to move that over to fit my 1 in there. So 11 plus 5 is 16. Now what I'm looking at is undoing multiplication or division. Well, I look for my variable. What's with my variable right now is multiplication. So to undo multiplication, I'm going to divide. I'm dividing by 2. Why am I dividing by 2? That's because that's what's being multiplied. So again, take a minute. This is a fraction, but a fraction bar means to divide. So I'm really dividing 16 by 2, and that gives me 8. Okay? So now that I've done those two, I want you to pause the video and try number 11 on your own. Okay, so let's see how you did. If I draw my imaginary line, I'm looking, my x is right here on the right this time. So what I want to do is undo any addition or subtraction. This symbol here is not subtraction right now. That's a -4. So I would subtract 9 from both sides. Then I get 13 minus 9, okay, which is 4 equals -4x. When I divide here, okay, when I'm doing this part, I want to bring not just the 4 over, okay, but take a look. I want to bring over a -4. By doing that, okay, I'm left with just x. But right here, I have negative 4, 4 divided by negative 4. That's going to give me a negative 1. Okay? How can I check that I'm right? Well, if I take my answer and I plug it in, and this is what I mean. I replace x with a negative 1. So 13 equals, well, what is negative 4 times negative 1? 4. Notice I'm just bringing the 13 down because there's nothing to do on that side. Well, what is 4 plus 9? 13. Therefore, I was right. Okay? So, let's try this one. Pause the video now and solve this equation. Okay, let's look. So, I'm not going to draw my imaginary line. You won't always see me do it. Can you do it? Of course. So, I'm going to subtract 7, and let me actually get a brighter color so you can see, because it might be a little challenging. Why am I subtracting 7? I hope you're sitting there saying, well, right now this 7 here, that is actually positive. This minus goes to the 3 behind it. So in order to clear this 7, I have to subtract it. It's gone. So I'm left with negative 3x equals. I'm going to come over to this side, okay? I'm doing 34 minus 7. Everyone with me? That's going to give me a 27. Now I have to undo the multiplication division. I'm looking here. I am multiplying by a negative 3, so I must divide by a negative 3. When I divide, I get x equals negative 9. Each one of these steps, I'm going to go back through and slow down for a second because I want to remind you. Here is 1 point. You showing me this is a point. We have another point when you rewrite your new expression. Then we go into another point when you show me how you isolate x. And finally, your last point. So really, this one question is worth 4 points. So if you were to just tell me x equals negative 9, you'd lose 3 points on an easy question. Okay? So let's go to my next one. This one is a little different. Okay, I'm just going to move this up so you guys can see the problem. Here's why it's a little different. If you take a look, I'm no longer multiplying with my x. So this term here has to stay. We're not going to touch it. Again, step 1 is still to undo addition or subtraction. Okay? So to do that, I would add 7 to both sides. What happens is I get x divided by 2 equals 16. 9 plus 7 is 16. So I'm looking at my variable. My variable right now is being divided. So I must multiply in order to get rid of that 2. And this is how I want you to start showing your work. I don't want you to write times 2. I don't even want you to write times 2. Okay? That is going to start confusing you when you start getting different coefficients. The reason is you're multiplying by 2 over 1. Look what happens. These cancel out. Therefore, I'm just left with x equals 16 times 2 is 32. Okay? I'm going to do this one more time, and then you guys get to try on your own. So again, this is right now one term. I'm not going to touch it. I'm going to subtract 8 from both sides. That leaves me with 3 equals x divided by negative 5. Again, this is why I'm telling you to show division with a fraction bar. That's how you're going to get it. So to undo division, and I know it's division because right here I see a fraction bar. I'm going to multiply, and I'm multiplying by -5, not just 5. So x is going to equal -15. Okay? So right now, what I want you to do is I want you to pause the video, and I want you to try this one on your own. Okay, so let's see how we did on number 15. Remember, we need to first isolate our variable term. I do that by bringing this 22 over to the other side. So what I'm left with on the left is 3/5 x equals 28 minus 22 is 6. Now, I need to isolate my x variable, meaning I need to get this by itself. Remember, when our coefficients of fraction, I can multiply by its reciprocal. What this does is it allows us to cancel out on this side, creating just a 1. Remember, we don't write that Ninja 1. But if I do it on the left, I must do it on the right. So now I have a whole number times a fraction. So I'm going to put my 6 over 1. If you know how to cross simplify, go ahead and do that. But I'm going to show you what most of you probably will end up doing. And I'm just going to do 6 times 5, which is 30. 3 times 1, which is 3. And I'm going to actually divide 30 by 3 and get 10. Therefore, the answer to this equation is 10. All right, so now I want you to pause the video one last time and try number 16 on your own. Okay, let's see what you got for x. So I'm going to bring my positive 1 over by subtraction because I do the inverse. So I'm left with -1/3 x equals. Now, right here, I want to talk about this. I'm noticing a lot of mistakes. You're adding these two, basically. You have a -7 and a -1. That's going to give you a -8. Okay? Now, when I bring this 1/3 over, most of you are probably saying, oh, the reciprocal, which is correct. But since there's a negative here, I have to make my reciprocal a negative. Why? Because a negative times a negative will result in a positive. Therefore, my fractions are gone. And I'm left with just an x. But if I do it on the left, I must do it on the right. So I'm left with a positive 24. So right now, you need to make sure you understand how to do these for our activity tomorrow.